So we'll continue with our series of solutions to the chemistry jam question, and today we are going to be looking at the 2023 question, the 2023 chemistry jam question. So the normal flow is I will start display the question, then thereafter I would tell you what the answer is, and tell you the reason why that answer was picked. But on your own part, I want you to also try to attempt the questions on your part, try as much as possible to see if you can come up with the answer. So I will look out for your response in the comment section while I just go over the questions one after the other. And then we go on like that till we get to the very last question. So let's delve in now. The first question says that what happens to the position of equilibrium if a reversible exothermic reaction is subjected to a decrease in temperature? Is it option A, option B, option C, or option D? So you tell me what happens. The answer is the position of equilibrium shifts to the right. And the reason is that in an exothermic reaction, heat is released as a product according to the Le Chatelier's principle. So decreasing the temperature favors the formation of more heat. That is the forward, that is the product forming direction. Hence, the equilibrium shifts to the right. The equilibrium shifts to the right, and that's the reason for that. Okay. All right, let's look at the second one that says that which noble gas is radioactive and is produced as a decay product of uranium and thorium. Is it argon? Is it krypton? Is it radon or neon? So let me know what you feel. The right answer is in the comment section. I'll be looking out for your response there. Okay. So I'm revealing the answer to this one. The option that is correct is actually option C, which is radon. And basically, radon is a radioactive noble gas formed during the natural radioactive decay of uranium and thorium. It is colorless, it is odorless, and found in some soils and rocks. So that's the answer. The third one says that which of the following reaction would be expected to have the highest entropy change? Is it liquid to gas, solid to liquid, gas to liquid, gas to solid? Okay. Entropy, don't forget, is the degree of disorderliness of the system. So from the options that you're looking at there, which one do you think will have a more disordered system between the options A to option D? Okay, so the right option is liquid to gas. That is from the liquid to the gaseous state. And basically, entropy measures the degree of randomness or disorder. So gas particles have more freedom of movement than liquids. So converting a liquid to gas results in the highest increase in entropy. Okay. Says, what is the sum of the oxidation number in a neutral compound? What is the sum of the oxidation numbers in a neutral compound? Is it +2? Is it -1? Is it 0 or +1? Okay, the answer to this one is C, 0. And the sum of oxidation numbers in a neutral compound is always 0 because the total positive charges balances the total negative charges. Okay. The fifth question says that according to the kinetic theory of gases, the pressure exerted by a gas is due to A, is it the vibration of gas particle, B, the weight of the gas particle, C, the attractive force between gas particles, or D, the collision of gas particle with the container. And the answer to these is D, the collision of gas particles with the container. Okay, container walls. Okay. The reason is because according to the kinetic theory of gases, gas pressure is caused by the continuous collision of gas molecule with the walls of the container. Each collision exerts a force, and the collective effect is the pressure observed. Okay. The sixth question says, what is eutrophication? Eutrophication, is it the release of harmful chemicals into water bodies, the excessive growth of algae due to nutrient enrichment, the presence of heavy metals in water, or the formation of oil slicks on water surface? The correct answer is B, the excessive growth of algae due to nutrients. And basically, eutrophication refers to the over-enrichment of water bodies with nutrients, especially nitrate and phosphate, often from agricultural runoff. And this causes rapid algal growth, which reduces oxygen in water and harms aquatic life. Okay. Question 7 says that what is the name of the process by which ammonia is produced on an industrial scale? Is it nitrogenation, ammoniation, nitrification, or Haber process? The right answer to this one is actually option D, is Haber process, and it's basically the industrial process through which ammonia is produced. Okay. The next one says, who proposed the planetary model of the atom with electrons orbiting the nucleus? Is it Henry Schrödinger? Is it Ernest Rutherford? Is it Neil Bohr or J.J. Thomson? Who proposed this model? The person that proposed this model is called Neil Bohr, and he proposed the planetary model of the atom in which electron moves in fixed orbits around the nucleus, similar to planet orbits in the sun. This model improved upon by Rutherford's earlier nuclear model. Okay. So the next one says, which of the following is an example of an endothermic reaction? A, combustion of propane to produce CO2 and H2O. B, burning of methane in the presence of oxygen. Formation of table salts from sodium and chlorine, and then decomposition of hydrogen peroxide into water and and oxygen. So which one is the example of an endothermic reaction? The answer is D, the composition of peroxide into H2O and O2. The decomposition of peroxide is an endothermic process. It absorbs heat to break down into water and oxygen. In contrast, combustion and salt formation are exothermic because they release heat into the environment. So we look at the next one, which says, what happens to the value of the equilibrium constant, Kc, for a reaction if the reaction is reversed? If the reaction is reversed, does it become zero? Does it become negative? Does it remain the same? Or does it become the reciprocal of the original value? Okay. So looking at other options, let me know what you feel the, the right answer is, please. So I'll reveal my answer and the reason for the answer. The answer is D. It becomes the reciprocal of the original value. So if a chemical reaction is reversed, the new equilibrium constant, Kc prime, equals to 1 over Kc. That's the equilibrium constant. So the reciprocal represents the shift in product or reactant ratio for the reverse process. Okay. What is the chemical structure of soap and detergent molecule? Is it hydrophilic head and hydrophobic tail, hydrophilic head and hydrophilic tail, hydrophobic head and hydrophobic tail, hydrophilic tail and hydrophobic head? So looking at all the options that we have there, the best one that can fit the question is A, hydrophilic head and hydrophobic tail. So it has a water-loving component and a fat-loving, or a fat-soluble component, so to speak. So soap and detergent molecules have a polar hydrophilic, which is water-attracting head, and a non-polar hydrophobic water-repelling tail. This structure allows them to interact with both water and grease, making them effective cleaning agents. Okay. So the next one says that what is the solubility products, or sorry, the solubility products constant, that's KSP, used for? What is the KSP, or solubility product constant? What is it used for? Is it to measure the total mass of a solute that can dissolve in a solvent? Is it to determine the concentration of a solute in a saturated solution? Is it to calculate the solubility of the solutes in a given solvent, or to compare the solubilities of different solutes in the same solvent? So the right answer to this is actually C, to calculate the solubility of a solute in a given solvent. And The reason is because KSP is an equilibrium constant used to predict the extent to which a compound dissociates in water. So it is particularly useful for sparingly soluble salts, enabling the calculation of their solubility. Okay. So this next one says that which trace gas in the atmosphere plays a significant role in the greenhouse effects? Is it oxygen? Is it argon? Is it carbon dioxide or nitrogen? Is it any of this? So please let me know what you feel it is in the comment section, and I would then reveal what the right answer is actually. So the right answer to this one is actually option C, carbon dioxide. And carbon dioxide is a greenhouse gas that traps heat in the Earth's atmosphere. Although present, although present in small amounts, it plays a major role in global warming. And okay, so that's that for that. So please let's take note of that. It's very important that so sorry, please. So the next one so this is says which of the following method can be used to remove temporary hardness from water? Is it boiling, filtration, sedimentation, or chlorination? So for temporary hardness to be removed, we can just use basic boiling, and that's option A. You can remove temporary hardness because it is caused by the presence of bicarbonate of calcium and magnesium. Boiling converts this bicarbonate into insoluble carbonate, which precipitates out, thereby removing the hardness. Okay. So okay, we'll move on to the next one now, and that's question 15. What is Faraday's constant? Is it 6.02 times 10 to the power 23? 3.00 times 10 to the power 8 meter per second, or 9.81 meter per second square, or 96,485 coulomb per mole. It is actually option D, so that's the answer. And it's a constant. Faraday constant is the amount of electric charge carried by 1 mole of electron. It equals approximately 96,485 coulombs per mole, and is essential in electrochemistry for calculating the amount of substance produced or consumed at electrodes. Okay. A gas occupies a volume of 1.5 liters at a pressure of 2 atmosphere. If the pressure is increased to 4 atmosphere, while the temperature remains constant, what will be the new volume of the gas? Is it option A, option B, option C, or D? If you do the calculation right, you will end up having this as the answer 0.75. And basically what we do is that we use Boyle's law. We've been provided with the force pressure and then the volume also. So what we are left with is to calculate V2. So when you apply the formula and you plug in the values that have been provided, you end up having a V2 of 0.75. That thing is 3 divided by 4, not which is equals to 34. So it's 3 divided by 4, which is 0.75 liters. Okay. Question 17 says stainless steel is an alloy made up of, is it iron and zinc, copper and tin, iron and chromium, or iron and carbon? The answer is iron and chromium. Stainless steel is primarily composed of iron, chromium, about 10 to about 20%, and sometimes nickel. So chromium provides corrosion resistance, which is the defining property of stainless steel. Okay. What is the state of matter in which particles are widely spaced and move freely with high kinetic energy? Is it liquid state? Is it solid? Is it plasma or gas? So the right answer to this is actually gas. In the gaseous state, particles are far apart. They move rapidly in all directions and possess high kinetic energy, unlike solid or liquids. Okay, all right. See, so the next one says that identify the reducing agents in the following reactions: zinc plus copper sulfate to give us zinc sulfate plus copper. So the reducing agent, is it copper? Is it zinc sulfate or copper sulfate? So the option is zinc. Zinc loses electron and is oxidized to zinc 2 plus. Therefore, it is the reducing agent because it causes the reduction of copper 2 to copper. Balance the following redox reaction: Fe2O3 plus CO to give us Fe plus CO2. And we have the options there. So when we balance it right, we will have our answer to be D. And the simple explanation is this. Iron 3 oxide is being reduced because we have to identify oxidation and reduction. So iron 3 oxide is being reduced to iron, while carbon monoxide is being oxidized to carbon dioxide. Now, the reduction half equation, that is iron is reduced, you have something like that, and that is what you have displayed there. So in Fe2O3, we have 2 Fe3 plus. So the full reduction half equation is Fe2O3 to give us 2 Fe plus 3 O2 minus. So we balance the oxygen atom by recognizing that the CO provides the oxygen to make CO2. So for the oxidation half equation, carbon is oxidized in this case. So carbon in CO has an oxidation of +2, and in CO2, it is +4. So it loses 2 electrons. So when we look at the balance equation, it will be Fe2O3 plus 3CO to give us 2Fe plus 2CO2. Okay. What is the trend for ionization energy across a period in the periodic table? Does it increase from left to right? Does it remain constant? Does it vary randomly? Does it decrease from left to right? The answer is that it increases from left to right across the periodic table. Okay, across the period, atomic number increases, nuclear charge becomes stronger, and electrons are added to the same energy level. This increased attraction makes it more difficult to remove an electron, so ionization energy increases. Okay. This one says, which type of chemical combination involves the transfer of electrons from one atom to another, resulting in the formation of oppositely charged ions? Is it ionic bond, hydrogen bonding, covalent bonding, or metallic bonding? Now, when we look at the options that we have there closely, the most suitable answer to this question is ionic bonding. Ionic bonding occurs between metals and non-metals. One atom loses electron, usually a metal, and another gains electron, usually a non-metal, forming oppositely charged ions. Okay. Which of the following alkanes has a straight chain structure? Has a chain structure. Is it cyclopentane? Is it isobutane? Is it 2-methylpropane or pentane? Which of them have or has a straight chain structure? Most definitely is not cyclopentane, so we need to start doing some elimination. And if you look at it critically, it cannot also be isobutane. It can be 2-methylpropane. So the best option that we have there is Z, option D, which is pentane. Straight chain alkanes have all carbon atoms connected in a single linear chain without branches. Pentane is straight chain, isobutane and 2-methylpropane are branched. Cyclopentane is a ring structure, so that nullifies that. So the answer there is pentane, C5H12. The next one says that what is the product of the electrolysis of aqueous sodium chloride using inert electrode? Is it option A? Is it option B? Well, is it option C or option D? So let me know what you feel the right answer is. Just drop it in the comment section, and then I'll reveal the answer and explain the reason why we are picking or choosing that particular answer. So the right answer is hydrogen gas at the cathode and chlorine gas at the anode. In aqueous NaCl electrolysis, at the cathode, H plus is reduced to H2 gas, not Na plus, as water is more easily reduced. So At the anode, Cl minus, as the chloride ion is oxidized to Cl2 gas, and that is what happens, okay? So the next one says, when an acidic solution is diluted, what happens to its pH? Does it depend? It depends on the specific acid. It decreases, it remains the same, it increases. So please let me know what you feel the answer is there, please. So the answer is it increases. Diluting an acid reduces the concentration of hydrogen ion, making the solution less acidic, which increases the pH value, moves closer to the neutral, that is pH 7. Which of the following factors does not affect the rate of a chemical reaction? Concentration of reactants, presence of a catalyst, molecular weight of product, temperature. The odd one out there is molecular weight of the products, and reaction rate depends on concentration of the reactants. Temperature also affects reaction rate, surface area, and the presence of catalysts affects reaction rate. But the molecular weight of the product does not influence how fast a reaction proceeds. Which organic compound is responsible for the characteristic aroma of fruits? Is it alkane? Is it alkyne? Is it ester or amine? So the answer to these is a ester. That's C, option C. Esters are known for their sweet, fruity smell and are responsible for the aroma and flavor of many fruits. Alkanes and alkynes are odorless. Amines often smell fishy. So that nullifies them. So the answer there is esters or ester. What is the molar mass of water, H2O? Is it 18 gram per mole, 22 gram per mole, 16 gram per mole, or 12 gram per mole? The answer here is A, 18 gram per mole. So you just work it out, very simple and straightforward. Looking at the constituent atoms that makes up the compound, you add them up, you add their relative atomic mass up, and then you have 18 gram per mole. Okay. So, what is the chemical formula of rust, which is formed on the surface of iron in the presence of oxygen and moisture? Is it Fe3O4, FeO, FeOH3, or Fe2O3? And the answer to that is D, Fe2O3. Rust is primarily hydrated iron 3 oxide, often represented as Fe2O3.xH2O among the listed options. So Fe2O3 is the best representation of the oxidized form of iron. Moving along now to the next one. How many pi bonds are there in an alkene with 6 carbon atoms? Is it 1? Is it 6? Is it 5 or 3? So the answer is 1. An alkene contains 1 carbon double bond, which comprises of 1 sigma and 1 pi bond. Regardless of the number of carbon atoms, a simple alkene has only 1 pi bond. Okay. What is the principal ore of iron from which iron is extracted? Is it calcite? Is it bauxite? Is it magnetite or hematite? The answer to this one is actually D, hematite, and hematite is Fe2O3 is the main ore from which iron is extracted in the blast furnace. Magnetite is another iron ore, but less commonly used than hematite. Okay, bauxite is an ore of aluminium. Okay, and calcite is calcium carbonate, not related to iron in any way. All right, so that nullified the 3 out, and the answer is hematite. Okay. Which group does calcium belong to in the periodic table? Is it the alkaline earth metals, the halogen, the alkali metals, or the noble gases? Calcium belongs to group 2 on the periodic table, and the group 2 are usually called alkaline earth metals. Okay. All right. See? Which of the following is a primary constituent of crude oil? Is it pentane? Is it ethanol? Is it heptane or methane? Which is a primary constituent of crude oil? And the answer is methane. Crude oil is composed mainly of hydrocarbon, especially alkanes. Methane is the simplest and most abundant component among light hydrocarbons found in natural gas, a component of crude oil. So that's that for that. Question 34 says, what is the main source of carbon monoxide in urban area? Is it volcanic eruption? Is it vehicle emission? Is it forest fires? Is it industrial processes? The answer here is vehicle emissions. And carbon monoxide is mainly produced from incomplete combustion of fossil fuels in urban areas. This is primarily due to vehicle exhaust from cars and trucks. 35 says, what is the empirical formula of a compound containing 40% carbon, 6.67% hydrogen, and 53.33% of oxygen by mass? Is it option A, option B, option C, or option D? Okay. The right answer here is C, option B, CH2O. And this is the solution. So to find the empirical formula, we convert percentages to grams. So assuming 100 grams sample. So we say C, which is 40 grams divided by 12, the relative atomic mass. So you just divide like that. After that, you divide by the smallest, and then you end up having carbon to be 1, hydrogen to be 2, oxygen to be 1. So that is CH2O, which is the empirical formula. Question 36 says, which separation techniques is used to separate different pigments in a mixture based on their affinity for a stationary phase and a mobile phase? Is it chromatography? Is it filtration? Is it decantation? Is it distillation? The right answer here is actually chromatography. And basically, chromatography is the separation technique that separates mixtures of substances, especially pigments or dyes, based on their different rates of movements through a stationary phase, e.g., paper or silica gel, and a mobile phase, e.g., a solvent. So it is widely used in forensics, biochemistry, and environmental analysis. Okay. Question 37 says that what is the common name for ethanoic acid? Is it acetic acid? Is it butyric acid, propanoic acid, or formic acid? The common name is actually acetic acid. And ethanoic acid is commonly known as acetic acid, the main component of vinegar. So formic acid is a methanoic acid, butyric acid is butanoic acid, and then propanoic acid is propanoic acid. So that's that for that. So we move on to the next one that says that what type of reaction is involved in the formation of alkanols from alkenes? Is it an elimination reaction, a redox reaction, a substitution reaction, a addition reaction? The answer is addition reaction. So the formation of alkanols, alcohols from alkenes, occurs by an addition reaction, specifically hydration, where water is added across the double bond and across the double bond of the alkenes to form an alcohol. So example, you have ethene, adding water to give us ethanol, CH2OH. Okay. All right. So moving on now, what is the mass percentage of carbon in methane, CH4? The molar mass of carbon is approximately 12 grams per mole. So what is the percentage of carbon in methane? Is it 25%, 12%, 75%, or 50%? The correct answer is 75%. The solution is pretty straightforward. We look for the molar mass of methane, and when we look for this, it's 16 grams per mole. Then the percentage of carbon is mass of carbon divided by molar mass of methane multiplied by 100. So when we do that, we have 12 over 16 times 100, and that gives us 75%. Okay. Which of the following is a common property of non-metals? Which of the following is a common property of non-metals? They exist at solid at room temperature, tend to gain electrons in chemical reactions, high thermal conductivity, readily form cations in chemical reaction. So the option here is tend to gain electrons in chemical reactions. Non-metals typically gain electrons during chemical reactions to form anions, as they have high electronegativity. Option A. Only some of non-metals are solid, e.g. sulfur. Now, others like oxygen are gases. Option C, if you look at it closely, says that high thermal conductivity is a property of metals. Then D, non-metals do not form cations, they gain electrons, not lose them. So the correct answer is that they tend to gain electron in chemical reaction. Okay. So this next one says that what is the symbol used to represent an alpha particle? Is it A? Is it option B? Is it option C or option D? The right option is actually A. That's the symbol that we use. And an alpha particle consists of 2 protons and 2 neutrons, the same as a helium nucleus. It's represented by the Greek letter alpha. Okay. When a substance is oxidized, it's A, loses electron, B, gains oxygen atom, C, gain electrons, and then D, lose proton. So when an substance is oxidized, what happens basically is that it loses electrons. Okay, oxidation is defined as the loss of electron. This process often results in an increase in oxidation number. Okay, a blue litmus paper. Okay, sorry. Let's continue. A blue litmus paper turns red when dipped into a solution. What does this indicate about the solution? A, the solution is basic. The solution is neutral. The solution is acidic. The solution is faulty. Or the litmus paper is faulty. Very funny option. Okay. So the answer to this is actually the solution is acidic. So when a blue litmus paper turns red, it means that the solution is acidic. And basically, that is just it. Pretty straightforward. Okay. Which of the following compound is an example of an electrovalent bond? Is it NaCl, CO2, H2O, or CH4? A very good example of an electrovalent bond is found in NaCl, that's sodium chloride. So because we have a metal, sodium transfers an electron to chlorine, the metal to form Na plus Cl minus. Okay. If gas A has a molar mass of 32 grams per mole and gas B has a molar mass of 64 grams per mole, what is the ratio of their diffusion rates? Is it 2 to 1, 1 to 2, 1 to 1, or 1 to 4? The answer is 2 to 1, and the reason for that is using Gram's law. We have rate A over rate B for the two gases, which will be equal to the molar mass of B over the molar mass of A. That is equals to the square root of 64 divided by 32, and that will be root 2, which is approximately 1.41. But for a precise ratio, it is commonly expressed as rate A ratio rate B equals to 64 root 64 ratio root 32. So that will be root 8 ratio 5.66, and that will be approximately ratio 2 to 1. So gas A diffuses twice as fast as gas B. Okay. The contact process is used for the industrial production of A, sulfuric acid, B, hydrochloric acid, C, sodium hydroxide, D, calcium oxide. The right answer to this one is actually sulfuric acid, H2SO4. So the contact process involves the catalytic oxidation of sulfur dioxide to sulfur trioxide, which is then used to produce sulfuric acid, one of the most industrially important acid that we have. Okay. This one says that which of the following is a unique property of water compared to other liquids? It is a pure solvent, a poor solvent. B, it does not evaporate. C, it expands when freezing. D, it has a low heat capacity. The right answer to this one is C, it expands when freezing. So water expands upon freezing, unlike most substances. This anomaly is due to hydrogen bonding and is responsible for ice floating on water. Okay. Sodium reacts vigorously with water to produce, is it sodium chloride and oxygen gas, sodium nitrate and water, sodium hydroxide and hydrogen, or sodium oxide and Na2, sodium oxide and hydrogen gas. So the answer is when sodium reacts with water, and it's a vigorous reaction, by the way, it will produce sodium hydroxide and hydrogen gas. And we can see the equation that way, and it's an exothermic reaction. Okay. Question 49 says that at room temperature and standard pressure, chlorine gas is in which state of matter? Is it plasma? Is it solid? Is it liquid or gas? The right answer to this is gas. It's always in a gaseous state at room temperature. Chlorine is a greenish yellow gas at room temperature and standard atmospheric pressure. And the final question says that what is the molecular geometry of a molecule with three bonding pairs and no lone pairs around the central atom? Is it a tetrahedra? Is it trigonal planar? Is it linear or octahedra? So the right answer to this is actually trigonal planar. So a molecule with three bonding pairs and no lone pair adopts a trigonal planar geometry with bond angles at 120 degrees. So example is boron fluoride, BF3. So that's a very good example. All right. With this, I want to say thank you for joining me as we have looked at the past question or the 2023 question, chemistry JAMB question. So the final one is the 2024, which we are going to treat very shortly. So stay tuned, and then I'll see you in the next video.